Welcome back to Mr. Powers Teaches Algebra. Here we got logarithmic functions, and these come after exponential functions. There's a good reason for that. They're related. All right? Much like addition and subtraction are related. So if you had a good elementary school teacher, they taught you the math facts. You know stuff like 2 plus 3 equals 5. And when that teacher taught you subtraction after addition, they would have taught you that it's not really a separate operation, that subtraction just undoes addition, or it's the inverse of addition, or it's like adding backwards. There's different ways you could say it if they taught you right. That way you're not learning something new. It's just still adding. It's just maybe we're thinking about it a little differently now. So when you learn something like your teacher then gave you a question like 5 minus 3, they said taught you, well, when you see something like this, what you want to think about is, what do you add to 3 to get 5? Well, we know that. It's 2. And a good teacher would have said, hey, these are math facts. These are equivalent statements. If one's true, the other must also be true. And that's the way you want to do it. Save yourself some mental exercise. Brain power is just to know this, and then we're just adding more. It's just more adding, right? And then subtraction's a piece of cake. So when we're talking about logs, you want to do the same thing. Okay. We were told a logarithmic function is something raised to the x. We could say, 1, 2. These are notes from before. We could say y equals b to the x, right? But a log, what we're going to say is the equivalent statement of, in this case, b to the y equals x. So let's switch y and x. In this case, if we have b to the y equals x, an equivalent statement for logs would be y equals log base b of x. These are equivalent statements, and we're just thinking the same ways. Instead of having both these numbers, the base and the exponent, what we got is going to be a base of the log, and then what we want to get when we raise that base to some power. And that's what we're looking for. We're looking for the y. We're looking for the exponent. We got b and x, and we're looking for this. Like, what do I do to get there? So it's still just exponents, but we're using a different notation. We're writing it differently. Okay. So this is what a log is. And we got restrictions on it, right? We got b is greater than 0. B cannot equal 1. Why is that? Because, back to here, remember, our base, b could not be 0 and b could not be equal to 1. This b is the same b, right? We always had that restriction for exponents. We talked about it there. So, of course, we're going to have that same restriction here. X has to be more than 0. Why? Because if you think about this as an equivalent exponential function or equation, or in the exponential form, we could say, then x would have to be greater than 0. Because remember, if b is greater than 0, and we're raising it to some power, no matter what, we're getting positive numbers. We can't get a negative or 0 over here. It just doesn't happen. And we talked about that when we talked about exponents as well. So we have very similar restrictions. And the way we say this expression right here, we'd say y equals log base b of x. All right. In this definition, y equals log base b of x is called the logarithmic form, and b to the y equals x is called the exponential form. They're equivalent. Okay, so that's where we're going to be going. All right. So with that in mind, let's do some problems. Let's look at a couple problems and see if we can compute some logs. All right, here are some problems. Let's see how many we can get done in a few minutes. So we have log base 4 of 16. Let's say equals, so let's go back to this. Equals y, right? So we'll make that our y. And if that's our y, we could rewrite this using the rule that we have, write it in exponential form because that's what we're used to. At least we'll do this for a little bit till we get used to these logs, or we can just do it forever. It's not really a very difficult step. And we say, well, b to the y equals x. So 4 to the y equals 16. We could rewrite it just like that. 4 to the y equals 16. Let me see. Am I zoomed in enough? Yeah, I guess so. Okay. And now we have it written two different ways. What is log base 4 of 16? Or what do I raise 4 by? What power do I raise 4 by to get 16? Well, that's easy. 4 squared is 16. So that tells me y equals 2. So what does this equal? This equals 2. There you go. All right. One more. Another one of these easy guys. Okay. Well, let's go ahead and keep the equals y. So that implies 2 to the y equals 16. So what do you raise 2 by to get 16? Now that's not a nice number. So I guess for that one, we would have to use a calculator. Hold on one second. Never mind. I don't know what I'm thinking. 2 to the y equals 16. You know what? So what is it? So 2 raised to some power. So 2 times 2 is 4, times 2 is 8, times 2 is 16. That's it. So actually, this is a little bit of scratch work. So I'm going to take this. We're going to move this over. And I got here that equals 16. So 2 to the 4th equals 16. So again, there's an arrow. If 2 to the y equals 16, y equals 4. There we go. So in other words, log base 2 of 16 equals 4. So on and so forth. Let me see here. I think we can do one more. And I think that'll be fine. You know what? I'm just going to skip down to the hardest question right here. And let's just see what we can do with this one. If we had this and we wanted to work it out in exponential form, what we would have is 3 halves raised to some power y equals 27 over 8. Now, it might be obvious to some, but in case it isn't, we can use rules of exponents here. And we could say, you know what? 3 to the y over 2 to the y equals 27 over 8. Or we can just notice this. Well, 3 cubed is 27. 2 cubed is 8. Y is 3. But I'll just say, you know what? So over here, let's go ahead and just write it out. 3 to the y over 2 to the y equals 27 over 8. Both cases, y, we'd have to have y be the same. So 3 cubed is 27, 2 cubed is 8. So that tells us y must be 3. That wasn't that bad at all. This guy would be negative. We got time. I lied. One more. This guy will be negative. Let's just get this, right? 5 to what power is 1 over 125? I think it's a negative 3. right? 5 to the negative 3. Since we haven't seen any negative powers yet, I'm like, let's take a look at a negative power. It's too much fun. I love this. So again, we can say, let's just make that equal to y. Use use our definition to rewrite it in equivalent form. We get 5 to the y equals 1 over 125. And here you want might to do what sometimes I like to do. There's lots of ways to do these. And say, you know what? I recognize this as a power of 5. So I could say that 5 to the y is 1 over 5 cubed. I recognize that's 1 over 5 cubed. And then, you know what? I can go further. I can get this to be the base on the right side. And I could just say, hey, 5 to the y equals 5 to the negative 3. Again, using properties of exponents. Well, here we go. It's quite obvious. Y equals negative 3. Anyway, so the more we do these, the quicker we can get at these. And we kind of see what we're trying to do. So I hope you found this useful. And until next time, enjoy doing math.